In this video, we're going to go over some programs in Chapter 10. So we're going to start with Program 10.1, which is called Creating the Taxes Dataset and Demonstrating the Data Line Statement. Well, the data line statement allows you to input or create a dataset with inputted data that you write inside the program. You don't really have to upload the data from a data file somewhere else. So this is useful when you want to do some sort of data analysis for a small data set, or if you just want to create a program and see how it runs on a trial data set, so you don't have to create a data set separate on a file and then use an in-file statement to upload it or whatever. You can just create the data set inside the code. So that's what we have here. So it's this part here. So program 10.1 goes from here to here basically. So we're creating a data set called taxes. It has these variables: SSN, the social security number of the person, the gender, and the answers to questions 1 through 5. Okay, so you use the statement data lines to tell SAS that what you're going to write after that is basically the data that you want to put inside taxes, right? This data set here. So as you can see, the book has more data points. I just picked 4 to exemplify this. So we have the ID for this first person, we have the gender, and the answers to questions 1 through 5. Now this in format statement that we have in the program tells SAS, again, we have done this before, but let's just reiterate this, that the variable SSN, social security number, is a character variable, and we're giving it 11 characters, right? 11 spaces or 11 positions or columns inside SAS. And then gender, which is also a character variable with only one character, which is this one. And then questions 1 through 5 are also character variables and with only one space. And we don't say anything about question 5 because basically it's just numbers. Now, this is a numeric variable. You don't have to put anything on the in format. Now, data lines, as I said, whatever you write after data lines, that's your data set. So, and then I have a proc print to see, to print this data set, the taxes data set that we have created. Now, this little statement here, ID SSN, changes, whenever you do input a data set into SAS, it will automatically create a column called observations or OBS, and it will give a number to each of the observations. Well, in this case it's immaterial because we already have a code or an ID for each of the variables, which is the social security number. So you may want to get rid of that observation column and just make the ID the social security number. So if we run this, you'll see that basically, okay, so we created a data set, social security number, gender, question 1, etc., etc., and the proc print prints the actual data table. You see, the observation column is now the social security number column. And there was here where I had a dot, that means that it's a missing observation, and therefore it keeps it blank. Okay. Now the data set taxes should be stored now under the work library because it's a temporary data set, right? There you go, taxes. Okay. Now, going back to the programming window here. Okay. Now the program 10.2 teaches how to create your own formats. So what is a format? Well, basically, you may want to change this for example, M, F, by, instead of having male, M or F, you want to have male, female, right? You want SAS to show that. Or perhaps here, this question 1, question 2, 3, and 4. You don't really know what they mean. So for example, we're informed here that 0 means no, 1 means yes. So I'm guessing here, right? On this. Well, not on that one. 0 means no, 1 means yes, and other means did not answer. Okay, other value other than 0 and 1. We're creating another format here called the Likert format, which is used for Likert types of scales, like strongly agree, neutral, disagree, strongly disagree. Usually it's like that. You have 5 options, and that's called a Likert scale. So we're saying, okay, we're saying SAS to recognize a value of 1 as strongly agree, a value of 2 as disagree, 3 no opinion, 4 agree, 5 strongly agree. Same thing, we're creating another format here called calls, and meaning A, we're telling SAS that A means none, B means 1 or 2, C means 3 to 5, D means more than 5. And then we're creating another format called pay group, which tells SAS that a number between whatever the smallest value is to 10,000 is considered low. From 10,001 to 20,000 is considered medium, and so on and so forth. Why do we want to create this? Well, basically because we want to apply this format to this data set, okay, to the numbers and the variables in this data set. So now we're gonna insert, after creating the format with the proc format, we're gonna make SAS change the variables here, or the numbers here inside the dataset taxes, using this format. So how do we do that? Well, with the proc frequency data taxes, because we're going to apply this format to this dataset, the dataset taxes. And then we're saying SAS, okay, format. What format are we going to use? Well, for the gender variable, which is this one here, we're going to use the gender format, which will will change M by the word male and F by the word female. In question 1, we're going to use the yes/no type of format that we created. Question 1 is this one here. So 1 means no. 0 means no, 1 means yes, another value will mean did not answer. So this is a yes, this is a no. We don't have any, anything else would be it did not answer. So this person did not answer, this person did not answer. Okay, now we're going to apply the Likert scale to questions 2 and 4. So question 2 and question 2, which is this one here, and question 4, which is this one here. And basically, for example, this value here, 3, will be changed to no opinion, right? And this 2 will be changed to disagree, and so on and so forth. So you see how it works, right? Now, at the end, I want frequency tables for all the variables, gender, and question 1 through 5, with the no cumulative. So basically, we only want the frequencies and the percentages, not the cumulative frequencies. So if we do this, if we run this part of the program, and this is, programs 10.2 and 10.3, no, well, actually 10.2 and 10.4 in your book, what do we get? So let's run it and see. Okay, so the result is that we have the tables, right? We have the tables that we requested for each of the variables. But now we have the format that we wanted. Instead of having F and M, we have male, female. Instead of having 0, 1, we have no and yes, right? Instead of having 1, 2, 3, 4, 5, or whatever it was, right? We have disagree, no opinion, agree, strongly agree. You see, it changed the values into whatever we made them to be with the format. Okay, so for example, in question 5, we had question 5, we used the pay group format. So this looks like it's the salary of the person or the income of the person, and we created these groups, right? These groupings from basically whatever the smallest value is to 10,000 would be low, 10,001 to 20,000 would be medium, and so on. So this person here, 23,000, should be in the high range, right? And this person, 17,000, will be in the medium range, and so on and so forth. And these tables are basically summarizing the data. It's telling me that we have 2 people in the medium range, 1 person in the high range, and 1 person, a very lucky person, in the very high range, right? So so that is, and these are the percentages. So as you can see, the cumulative frequencies were not included, and here frequency missing equals 2, meaning that 2 people did not answer question 1, right? So that's pretty much it. Now you can also create labels for the variables. Instead of having, question 1, question 2, question 3, you could label the questions, like, do you pay taxes for question 1? Are you satisfied with the service, question 2? All of that is in program 10.7, which is pretty self-explanatory, so I'll leave that to you to go over it. It's just before the input statement here, or after it actually, you will use a label statement. Okay, so for example, let's say label question 1 will be labeled as do you pay taxes? Okay, do you pay taxes? And then I'm not going to do the other ones, I'm just going to do that one, so I have to put a semicolon, right? So if we run this again, all of it, you see, in the table, instead of having question 1, we have do you pay taxes. So it's changed the names of the variables by whatever label you want to give it. So you could do the same thing for question 2, question 3, question 4, and question 5. And it's good if you do so, right? Or because this is more explanatory, right? This is saying that 1 person said yes, 1 person said no, and 2 persons did not answer this question, do you pay taxes? When you have only question 1, if you're not the person who actually created the data set or collected the data, you will not know what question 1 means. So it's always good to have labels.